Okay, so hello people. So today we'll be solving LeetCode daily question 1743, that is restore the array from adjacent pairs. In this, there will be an integer nums that will be containing n unique elements, and but I have forgotten them. Okay, and however, I you do remember every pair of adjacent elements in nums. Okay, so in this we'll be given a 2D integer array adjacent pairs of size n minus 1, where each adjacent pair I will be equal to ui vi, that indicates that element ui and vi are adjacent in nums. Okay, and it is granted that every adjacent pair of elements nums I and nums I plus 1 will exist in adjacent pairs either as nums I plus 1 or nums I plus 1 comma nums I. Okay, so it means that basically the in the array they can exist as ui vi or vi ui. Okay, and the pairs can appear in any order. Okay, and what we have to do, we have to return the original array, and if there will be multiple solutions, we will have to return any of them. Okay, so first let's see towards the explanation of test cases. In the first test case, I am given the pairs 2 1, 3 4, and 3 2. Okay, so and the solution to this is 1 2 3 4. As we can see that it is given that 1 and 2 should occur together, and this 1 and 2 are occurring together. 3 and 4 should occur together. 3 and 4 are also occurring together, and 2 and 3 are 3 and 2 should occur together. Okay, so this is one possible solution, or the other possible solution could be 4 3 2 and then 1. In this also we can see that 4 and 3 occur together. This is true. 3 and 2 occur together. This is also true. And 2 and 1 occur together. This is also true. So this might be also a possible solution. Like in the other test case, we are given that 4 and minus 2 should occur together, 1 and 4 should occur together, and minus 3 and 1 should occur together. Okay, so and the output for this is minus 2 4 1 minus 3, or the other possible output could be minus 3 1 4 2. Like it means that the we can return this reverse order of that array also. Okay, and adjacent pairs for this it's just one pair, so I guess that there was some error, so it has just ignored, but here it should exist minus 1 2 3 4 5. Okay, so this could be the answer. Okay, so let's say what I want to tell, that we should not consider, like let's consider that this is not an array, instead it is a graph. Okay, so let me just explain. Like in the first test case, I guess the test case was like this. It was the array of 2 1 and then 3 4 and then 2 3 or 3 2. Okay, 2 3. Okay, so let me just check. 2 1 3 4. Okay, 3 2, here it is. uh, 3 2. Okay, so this was the test case which was given. So let's consider these are the edges between any two nodes of the graph. Okay, so what I'm trying to say is, let's say this is one node, and this is second node, this is third node, and this is fourth node. Okay, so what these adjacent pair represent is that there is an edge between 1 and 2, or 2 to 1 we can say, and there is an edge between 3 to 4, and there exists an edge between 3 and 2. Okay, so what we can do, we can solve this question as a graph, and what we will be considering, that firstly we'll be trying to find the root node. Okay, so how we can find the root node is, like this can also be my root node, or this can also be my root node, because both of them has are connected to just one other node. But in case of 2, the degree is 2, and in case of 3 also the degree is 2. Because why we are considering 1 and 4 as to be the root nodes, because we know like the answer was 1 2 3 and 4. Okay, as 4 and 1 occur at the extreme ends, it is only possible for them to have one connected node. that is in case of 1 it should be 2, or in case of 4 it should be 3. So that means that these are the only possible two nodes which we can have, and except for that all the other two nodes, like let's say for 2 we can see that it is surrounded by two elements, so clearly its degree is 2. In case of 3 also the degree is 2, but in case of 4 and 1 the degree will always be 1, and this basically means that in the elements that will be present at the extreme ends will always have a degree of 1, because there can't be any element here and also not here. Okay, so what we can do, we can simply do the firstly we'll be forming a graph out of the given indexes, and then we'll be finding the root node, and then after that what we'll be doing, we'll be finding the solution to the this question. Okay, so okay. Okay, so yeah, so let's just start with the pseudocode. So what I'll be doing, I'll be firstly creating a hash map data structure map of basically integer and a list of integer to store the adjacent nodes and the node which through which all the node and its adjacent neighbors. Okay, so and then let's call it graph only, and then what I'll be doing, I'll be assigning the values to the graph. So I'll be for int I in nums. Okay, so what we can say that let's say and x will be, okay, let me just delete, and yeah, x will be equal to I of 0 and y will be equal to I of 1. So what we'll be doing, we'll be just simply adding graph dot put graph dot basically get x, and in that we'll be adding y, and similarly in graph dot get y we'll be adding x, because what does this basically means, that there exists if there exists a edge between 1 to 2, there also exists a edge between 2 to 1. So we'll be have to add both the edges to both of them, like one will be 2, and for 2 also we'll be adding 1, and for we'll be adding 3 also, and this is how, and for 3 we'll be adding 2 and 4, and for 4 I'll be just adding 3. This is how my hash map will look. Okay, so yeah, so I'll be just adding all the elements like this, and then after this, let's say my I'll be considering that my root is 0, because it is given that we are having n minus 1 element. So I am just considering that I'm not having 0 in that particular graph, and my root is 0. Okay, so now let's say we'll be traversing in the key set of the graph, or in let's say I in graph dot key set. So what I'll be basically doing, firstly I'll be checking that if graph dot get I dot size. So what okay, let me just write, and that I'll tell is equal to 1. So that means that is my root is equal to I, and here I'll be just breaking it out of the loop. Okay, so what this for loop basically will tell me that what is the root, because as I have already told that in case of 1 and 4, it is only possible that we will be having the list of integer size as 1, because these will be our root nodes, just 1 and 2, because in either else any case, let's say I'll be checking it for 2, so I'll be receiving my list size at 2, and in case of 3 also I'll be receiving my list size is 2, but in case of 1 and 4 I'll be retrieving receiving the list size as 1. So I can clearly see that these are my root nodes. Okay, so and after that it's just simple, we just have to create an array. What I'll be doing, I'll be creating my answer variable, and I'll be setting my current pointer to root, and let's have an answer variable of size graph dot size, because we'll be having that particular number of nodes. And what I'll be setting, that answer 0 will be equal to root. Okay, and let's have a previous variable that, and I'll be assigning maximum possible value to it because okay. So then while, okay, and also a variable I'll be initializing it from 1. Then while I is less than graph dot size. uh, okay, so what I'll be doing that for I, okay, I'll have to consider j in graph dot get current, and what I'll be doing for every, and I'll be checking that if I should not be equal to my prev, that means that we shouldn't have visited that. So what I'll be doing, I'll be assigning a answer I will be equal to j, and here what I'll be doing, I'll be just moving to the next index, and I'll be setting my prev to the current and my current to the j, and after that I'll be breaking out of the loop. Okay, and at the end what I'll be just simply doing after these loops, let me just close them. Yeah, I'll be just simply returning answer. Okay, so this is how we'll be approaching the question. So now let's move towards the coding window for it. So let me just zoom in. uh, yeah, firstly I'll be having a hash map data structure of integer and a list of integer. Let's call it graph, that will be equal to new hash map. And then what I'll be doing, that for int edge in adjacent pairs, int x will be equal to edge of 0 and int y will be equal to edge of 1. And what I'll be doing is firstly I'll be checking that if not graph dot contains key x, what I'll be doing, I'll be just graph dot put put x, and then I'll be doing, I'll be adding a new array list to that. So I'll be doing the same thing for y also. If graph not contains key y dot new array list, and here what I'll be doing, I'll be doing graph dot get x dot add y. Similarly graph dot get y dot add x, and by now I've just made the graph out of the given adjacent pairs. Okay, so let me initialize my root variable now, that will be equal to 0. Then for, and let's say uh, let's call it okay, I in graph dot key set. So what I'll be checking that if graph dot get I dot size equal to 1, what I'll be doing, I'll be setting my root will be equal to I, and I'll be just breaking out of the loop because I have found my root node. Then I'll be initializing a current variable that will be pointing towards my root, and what I'll be doing, I'll be having a answer variable, a new integer of graph dot size, and then I'll be setting answer 0 will be my root variable. Then I'll be also having a previous variable integer dot max underscore value. Okay, then while I is less than graph dot size, I'll be traversing all the nodes. Then for int, let's say node in graph dot get current. I'll be traversing in the adjacent nodes of my current route or current node. Okay, so then what I'll be doing, that if my node is not equal to my previous node, what I'll be doing, I'll be setting answer I will be equal to node. Okay, I forgot to declare answer int I, that will be initialized with 1 because we have already set the value for 0th index, and then I plus plus, and then I'll be moving my prev will be equal to current, and my current will be equal to the node. Okay, and after this I'll be just simply breaking out of this for loop, and at the end I'll be just simply returning answer. Now let's run it. And it gets accepted. Now let's submit it. And yeah, and it gets submitted and it works fine. Okay, so this was it for today. Thank you for watching.